Hi guys, so we're going to talk about the properties of logarithms. Remember last video I did the logarithmic functions, just an introduction. So now we're going to talk about the properties of logarithms, and we're going to start with change of base formula and then move to the properties so that we can expand and condense logarithms. So you can see I already have a lot of things posted here. So if we want to change the base, if we want to change the base of a logarithm, I have two formulas here. So this is the general formula, which we can really use for this too, but being that it's base e, you can see that we're going to use ln of x over ln of a instead of saying log base e of x over log base e of a. So you can see with this formula that we can use that for pretty much any base that we want to change it to, including e, but if you're going to change the base e, it's just easier to use this because it's going to be written as ln of x over ln of a. So that's the only reason why I have the two. So let's look at problem number 1. So we have log base 4 of 30, and we want to change that to a common log. Now remember, common log is log base 10, So using the formula, if you want to change to log base 10, we would say that this is log base 10 of x. Now remember, x is the 30, based on the formula, over log base 10 of a, which is 4. Put that here. Now remember that a lot of times with log base 10, the common log, you're just not going to see it written. So to say the log of 30 over the log of 4 is probably how you're going to see it. It's perfectly fine. All right, and then changing log base 4 of 30 to the natural log. So that is where this over here is going to come into play, which is why I put that there. So remember that the x value and the a value. So this will be ln of 30, ln of x over ln of a, which is 4. So ln of 30 over ln of 4. So that's how you can change the base of a logarithm. So let's talk about the properties, which I have again posted here. It's just easy instead of spending the time writing them. And what you'll notice is they're very similar to the properties of exponents, because again, what is a logarithm? A logarithm is just an exponent. So if you recall from properties of exponents, if you multiply, you say you have x squared times x to the third, what do? You add those exponents. Well, look what we have here. When we are multiplying, you have log base a over u times v. And I know, I'm sorry, this actually, it looks like a u as well, but there is a difference, so hopefully you can tell that's a v. So if you're multiplying, so you have log base a of u times v, well, that we can separate into log a of u plus log a of v. So again, we're multiplying, properties of exponents, multiply, what do you do when you add? So you can see that's directly tied together. And of course, the same holds true for ln. ln of uv will be ln of u plus ln of v for the natural base. All right, and then in b, we're dividing. Well, think back to exponents as well. If you have x to the third divided by x squared, what do you do with those exponents? You subtract. So here we are dividing. So log to base a of u over v is equal to log base a of u minus log base a of v. Same thing, divide, we subtract the exponents. And of course, that holds true for the natural base. And the last one we have here, so you have log base a of u being raised to the end, and that is going to equal n times log base a of u. So in essence, what you're really doing is you are dropping that down into the front as a multiplication. And remember, when you have, with properties of exponents, if you have an exponent being raised to another exponent, what do? You multiply that. So you can see how they're all tied together. related to the properties of exponents, because again, a logarithm is just an exponent. And of course, this property holds true. ln of u raised to the n is equal to n times ln of u. So let's look at some examples of how we can use these properties. So let's say that we want to write this expression, ln of 2 over 27, in terms of ln of 2 and ln of 3. Meaning we want to write this, and we can only use those two. We can only use ln of 2 and ln of 3. So how can we go about doing that? Well, think about the properties. If we're dividing, so ln of 2 over 27 means we can say that this is ln of 2 minus ln of 27, because we're subtracting. When you divide, we subtract. Well, we still don't have just ln of 2 and ln of 3. We have the ln of 2 here, but now we have 27. Well, what can we do with this 27 in terms of getting it to be a 3? Well, can I say that 27 is 3 to the third? Ln of 27 is 3 to the third. So now I have this ln of 3 right here. Now, of course, I have a raised to the third power, but we can use the property and say that this is going to be ln of 2 minus 3 ln of 3, because we're going to drop that down into the front. So now I have this written in terms of only ln of 2 and ln of 3. So this would be the answer for that. All right, let's look at this one here. So we want to write the expression ln of 75 using only ln of 3 and ln of 5. All right, well, what I can do here is I can say that this would be equal to ln of 3 times 25. So that takes care of, I have an ln of 3 in there. But then we look at 25, I'm like, well, how can we get that to be a 5? ln of 5. Well, we can say that this would be 3 times 5 squared. See, so now I have the 3 and I got the 5. So using the properties, it's multiplication, which means that's going to be addition. So I have ln of 3 plus ln of 5 squared, which of course we drop that 2 down in the front using the properties. So I have ln of 3 plus 2 ln of 5. And then that gives me only ln of 3 and ln of 5. And that is the answer. All right, so let's go to expanding and condensing. So let's say that we have this expression right here, and we want to go ahead and expand that using the properties. Well, we know when you are multiplying that that actually is addition. So log, and now there's no base written, so we know it's base 10, 5x to the third y. So that is going to be equal to log of base 10 of 5, or log of 5, plus log of x to the third, plus log of y. So now the only thing I have left to do is just drop this 3 down in the front, and that gives me log 5 plus 3 log of x plus log of y. And that's all we can really do to expand that out. All right, now let's go the other way. Let's go ahead and condense. Let's go ahead and condense this log. So what I'm going to do, I'm just going to rewrite it here quick. So notice I have these terms in the front, the multiplication, so I can bring those up here as the exponent. So this would be log x to the 1/2 plus log x to the third. All right, well now since I'm adding, that is multiplication. So this would be log x to the 1/2 times x to the third, because again, addition is the multiplication. Well, when I'm actually multiplying this right here, what do you do with the exponents? Well, you add them. So this would be log x to the 1/2 plus 3, which would give me a final answer of log x to the 7/2. and that would be my answer. All right, let's look at this last question. So now we want to solve for x. We can use the properties and we want to solve for x. Well, basically I'm going to need to kind of condense those in order to be able to solve for this x value. Well, I know with subtraction that is going to be division. So I can say that this side would be ln of x plus 8 over x because it's subtraction. And then over here, I can bring the 3 up to the top as an exponent. That's ln of 2 to the third. Now, of course, we can just say that that is ln of 8. So going back to properties in the first section, the introduction, if I have ln of this and ln of this, I know that they have to be equal. So I can say x plus 8 over x is equal to 8, because again, 2 to the third is 8. That is my equation that I'm going to solve. So solving this, I can just go ahead and multiply that up there by x. So I get x plus 8 is equal to 8x. And then I'm going to go ahead and move this x over, so subtract that. And I get 8 is equal to 7x. And I think you see where this is going. We divide by 7, so I get x is equal to 8 over 7. And that is it. So hopefully this helps you with the properties of logarithms. And in the next lesson, we're actually going to solve exponential and log equations. So I will see you on the next video.